Okay, everyone, this is right at the top of the hour. We're going to go ahead and start our presentation. My name is Tim Chen, the product manager for the Backup Recovery Technologies. With me today is Marco Calmasini, who will be starting off a presentation on using RMAN for database platform migration, specifically cloud platforms, environments. And I'll be talking to using Recovery Appliance for doing migration as well. For cloud and on-premise environments. So this is our AskTOM Backup Recovery Office Hours series. We'll be taking chat questions we'll go ahead and start. Then Marco, are you there?
I'm here, yeah. Can you hear me?
Yes, thank you.
Okay, yeah, thank you, Tim. Yes, so my name is Marco Calmasini. I'm one of the product managers working with Tim on backup and recovery. And yeah, what I'm going to talk to you today is really a very high-level overview of options for migrating databases to the cloud using RMAN. Right? There are many ways of doing that, but obviously those that involve using Recovery Manager and cloud backups. So yeah, can you go to the next slide, Tim? Mm-hmm. Yeah, okay. All right. Well, cloud backups are, a very popular solution. Many customers are now using cloud storage as a destination for their backups. The advantage, and I'm not going to this, but because it's clear the advantages of having a virtually unlimited storage location, which is offsite, and yeah, you don't have to worry about tapes and then moving tapes down, etc. Are clearly and clear to everyone. Once you move your back or you do your backups to the cloud, you also have the options of easily restoring those backups in the cloud or anywhere, basically anywhere you have target connect or you have network connection to that cloud storage location. So it's comes very easy. The idea of using those backups to, for example, instantiate cloud databases for test dev, for example, or maybe standby for hybrid DR solutions for using DataGuard, and also to migrate your workload to the cloud if, over time, the decision to completely move the workload to the cloud comes. So can you go to the next slide, please, Tim? So this is what we will look at today. Backing up directly to the cloud from the database you're protecting is not the only option. Another way of having backup stored in the cloud can be, for example, using the ZDLRA archive to cloud feature, where you're backing up locally on premises your database using incremental forever to the recovery appliance, but that you can use the recovery appliance to create full backups for your database in the cloud, either for long-term retention or for extending your recovery window. The ZDLRA, and there will be more details coming later in Tim's part, can really act as a kind of migration engine, to migrate databases and to facilitate conversion, etc. Can you go to the next slide, please? Okay. So if you are really planning to migrate a database to a cloud instance, there are many considerations to make, right? It's not a straightforward job when it says, okay, I have this database, any type of database, I back up to the cloud and I have to store it in the cloud. I mean, it can be in part if you are restoring to a compute instance where you manage your database, you at that point you install your database version and you configure it how you like. It's a different. But if you want to migrate to a database cloud service or to an Exadata cloud service instance, then you have to consider what type of backups, what type of databases those services support, right? So database version is the first thing to consider. In the cloud, only 12.1, 12.2, and 18C, I think it's still 11.2, are supported. Some of them will be retired in January, etc. So not all the versions are available. You have to consider what your host operating system is for your on-premises database. In the cloud, you only have Linux, and so you may have to go through a conversion, right? An Endian's conversion if your database is running on AIX or HPUX or Solaris. You have to consider the character set. Okay? Your cloud database character set must be a superset of your on-premises database. And also, in the cloud, if it's 12c or later, we only support multi-tenant databases. If your on-premises database is not multi-tenant, you also have to plan that you have to convert it to a PDB, basically in a multi-tenant configuration. And then, yeah, you have amount of data, also important. If you're already doing backups to the cloud, that you may have already figured that out. Bandwidth is usually a big constraint when going from on-premises to cloud storage, and there are physical limitations. You can only move certain amount of data over the bandwidth you have available, and that has to be considered. You have to consider the downtime that you can afford when migrating to the cloud. You have to look at storage for staging data. Some of these procedures include data pump, for example, so that's another thing to consider. And yeah, network bandwidth and system outage. Can I go to the next slide? Okay. If you look at the OCI documentation, there's some more details on the options. There are also more options. Like you can do remote cloning, you can do data pump, you can do unplug and plug of a PDB. You can use SQL Developer. Yeah, consider that this method, for example, cannot be used, that I'm going to present, cannot be used with autonomous databases because you don't have access to RMAN in those cases. So you will have to probably use SQL Developer or other methods to really move your data. And export, import it at that point is basically the only option you have. So the things we will look at are really RMAN related, the one that is on the left side of this table, right? So closed platforms, supportable PDBs, and the conversion and duplicate from active databases. So can you let's go to the next slide? So we'll look at, again, these are not exhaustive. These are not all the things you have to do, but these are the main steps that you have to take. For example, if you want to use an RMAN closed platform transportable PDB approach, right? This assumes that your source database is either already a PDB or it's a non-CDB. Okay. If it's already a PDB, you can unplug that PDB from the existing CDB, and then you can do a backup directly to cloud storage using for transport, and at that point you end up having a local XML file created by the unplug operation on your source database, or if it was a non-CDB, you have to execute that procedure PDB. When you go to the cloud, you copy that file using SCP, you copy the encryption wallet in case, and you move it to the cloud, and at the point in the cloud, you catalog the backup pieces, and you can do a restore all foreign data files operation. You create the pluggable database. If the original database, the source database, was a non-CDB, that is also another procedure that you can run to delete unnecessary metadata created by your restore operation, and then you can do an alter pluggable database and open the database. To do this, the source database must be little Endian, because there is no Endianness conversion in this type of approach. So this works if your source database was, I don't know, running on Windows, for example, you're going to Linux, so it's already a little Endian. And yeah, that's kind of a straightforward operation. And yeah, I presume you're in 12C. Can you go to the next slide? It's similar approach, but in this case, you are using data pump, and you basically create a local directory to store your data pump or the metadata information. You are using this approach if you want, for example, move only certain table spaces, right? So you can migrate a specific table space, you put it in read-only mode, you do a backup for transport to the cloud. Okay, so your backups will be sent directly to the cloud, and at that point you do a copy using SVP of the data pump files and of the encryption wallet in the cloud, and when you prepare your cloud instance, and at that point you catalog your backup pieces, and you can just do a restore of your table space to the new destination, and that's it. It's assuming that your database is already set up and prepared in the cloud with all it needs, and you are only moving certain table spaces. Can you go to the next one? Okay. This is also similar to the previous one, but in this case, we also had platform conversion. So in the previous case, you had to be on the same NDNS. Okay, so your source database had to be little endian. In this case, we assume you are migrating a table space that is running on Solaris, for example. And it's very similar. You prepare your source database, creating the directory where you can store your data pump files, put your table space in read-only mode. You back up the table space to the cloud, to cloud storage, and when the backup is done, you copy your data pump files, encryption wallet to the cloud. You prepare your instance in the cloud, and you can do restore, specifying the from platform operation. And in that case, your restore is restored directly and converted on the fly. If you're in a 12C database. If you're in an older version of your database, you may also have to do a restore first and then do a convert after that. Can you go to the next one? Okay. This is another way of doing this migrations. In this case, we are going to duplicate from an active database. In this case, the database must be on the same version. So you may have to upgrade or patch your source database so that it's matching the same version that's stored in the cloud. And what you're going to do, you are basically, prepare your target instance, create the listener, the wallet, configure the storage, and everything in the cloud database must be configured in the same way as you have in the source side. You have to make sure that your source database is reachable on port 1521 or whatever port you're using for SQLnet, because you need to connect directly from RMAN running on the target side to your source database. And this is also a pretty common operation for DBAs to perform this duplication from an active database. The only thing I wanted to highlight it was supposed to be green, the same screen, is that if you're using 18C, that is an interesting option, which is that you can now use as encrypted for your duplicate target database command in RMAN. So if the source database was not encrypted, you don't have to go through encryption, either before migrating or immediately after the migration. You can just do a duplicate target database to the destination database as encrypted from active database, and RMAN will duplicate your database and encrypt it on the fly. I think, go to the next one. Please, we have another thing to consider. Okay, so all the previous examples assume that you had enough network bandwidth to do these operations within the downtime you have. If you don't have enough network bandwidth, and obviously, unfortunately, you still have to consider some downtime, maybe long, but if you have like hundreds of terabytes or maybe petabytes databases that you really want to lift and shift and migrate to the cloud once and for all, transferring over the network may not be the best option. So there is another option that is using the storage cloud transfer service. And it basically means that you're going to do a local backup of your database on local disks. Either it's a storage appliance or it's USB connected drives. Okay, it's any kind of supported storage that can be used to be shipped to Oracle, and Oracle will load that those files, so the backup pieces, in object storage for you, so you don't have to transfer them over the network. The thing to consider here is that the format that RMAN uses to store backup on local disks, so when you do your backup on the source side in this case, and the format that RMAN expects to find when you are addressing your backups to the cloud storage are different. So the thing to consider here is that you have to basically convert your backups once they are loaded in the cloud storage for you, and they are loaded in the same format they were on the source disk. So they are basically just copied over the cloud storage device. Then you have to use RMAN. There is this export backup piece command that you have to use to let RMAN create the metadata it needs to be able to do a restore. Then the restore proceeds as normal, so you can basically go back to the previous examples and use the same approach. But the thing I wanted to highlight is that your backup must be encrypted on disk, first thing. And second, you have to use this export backup piece command to be able to then actually catalog the backup pieces and restoring them. Okay. So yeah, this is what just high-level example of available options. There are many other options that do not include RMAN, and again, like export, import, or other SQL developer or other options that are covered in the documentation. So if you go to the OCI documentation and look for database migration to the cloud, you will find more details. And if you have questions, we can go through some of them later, or just reach out to us and we'll try to help you. Okay. Tim, I think you can go ahead.
All right, thank you, Marco. So that was a good survey of the RMAN-based techniques for database migration. You might have been familiar with some of them already, but in the context of cloud, there's various methods, as Marco mentioned. What I want to present on is using the recovery appliance, our engineered system for data protection of Oracle databases, as a means to get databases from one platform to the other. And specifically, we're talking about converting to Linux, Exadata on-premise, and Exadata Cloud at customer systems. Those are from our customer base. One of the most pressing needs is as they're looking to do movement into our engineered systems, consolidation into a cloud model. They want to have an easy way to do this. And so the techniques that Marco presented was from an RMAN kind of database level. We want to present something here that's specific to recovery appliance, and I'll go through kind of the points and the benefits of using this. Okay, so first, just a quick solution overview is we have basically databases that have to be moved to a new platform, and we have the recovery appliance serving as kind of the migration engine to be able to get the databases onto the new destination platforms. And I'm going to walk through the overall procedure to do this cross-Endian, that is from a little to big, big to little kind of scenario, or even secondarily to do a Same-Endian platform database migration, which requires less steps and less downtime, et cetera, than even the cross-Endian platform solution. Okay. So to catch everybody up on Recovery Appliance, the Zero Data Loss Recovery Appliance is our engineered system. It's designed to protect all your databases in your data center. It uses your familiar RMAN backups to do so, as well as using redo transport. So what we have is a strategy where we're only sending the incremental backups to the Recovery Appliance, so one level 0 full, and then incrementals forever. And we're also using redo transport to send all the ongoing transaction and changes to Recovery Appliance and being captured. Okay, so the solution was to be able to centralize this kind of process for lots of databases, large volumes of databases, to work on Oracle versions going back to 10.205 into now 18C, and also to be able to do this very and efficiently from an administration standpoint. So, so having your backups sent to this Recovery Appliance, they are validated, they are compressed, right? They provide full restore capabilities, just as you would expect, point-in-time recovery. And we use EM to administer and manage this system as well, right? The backups can be offloaded, or we call archived, out to the cloud storage. This is one of our recommended places to put long-term archival type of backups. So the Recovery Appliance can have a policy set up to be able to copy your standard RMAN full backups, incrementals, archive log backups to the Oracle Cloud Storage. You may also choose tape as a means to do so as well. And so we work with our own media management software called Oracle Secure Backup. We also work with all the other third-party media management software vendors today that integrate with the Oracle database. And finally, we have replication for DR capability. So to have a copy of all the backup data also replicated to a secondary appliance where it can be used for tiering to the cloud, to tape, for restore purposes, right? Most of our customers today have at least one local or one remote recovery appliance for DR purposes. So the virtual full technology is kind of where this migration is built on, but just to walk this through and give you some background, what we're talking about is creating an initial level 0 backup to Recovery Appliance as normally you would for your backup storage. But then every cycle to only do a level 1 incremental, only the change blocks, okay, that are backed up to Recovery Appliance. And the appliance creates what we call a virtual full. This is a metadata representation of the physical full backup as of the point of the incremental time. So you get essentially a new full backup known to RMAN created automatically for you by the system without having to take a new full backup to begin with. So you're saving quite a bit of time and space by just doing incremental forever. And you can do this for any number of days. The appliance will have the policy for retention, so you set how long you want to keep these virtual fulls around, and the appliance will purge the older backups as needed over time. We also do virtual full restores. So when you have a restore request coming in from RMAN, very standard restore database to a particular day or SCN time kind of format, the system will take, the RMAN client will connect to the Recovery Appliance. There's a catalog actually in there that's used to find the proper backups. And those backups are virtual fulls. And what the system will do is to reassemble the blocks from those previous days incrementals into the proper physical full backup as of that time that's needed and return it back as a physical full backup. So you're saving the time from having to restore and apply all those incremental backups in the traditional full and incremental strategy. Right? And this system is built on Exadata hardware and storage components. So it's designed to be very performant, resilient. All the features and characteristics of an Exadata system is also leveraged now for your data protection solution. So with that background, let's talk about how that virtual full and restore process is used with the database migration. So some of you may know, some of you, I didn't know this, but the big Endian, small Endian kind of background came from Gulliver's Travels, where they had subjects of the emperor who complied with his orders. They were called little Endians, and those who rebelled were called big Endians, okay? And so relating to the side of the egg, right? By opening their eggs at the large end, they were called big Endians. So this kind of got transferred over to computer architecture, where in big Endian, you've got the addressing memory, starting with the most significant bit stored first, and with the little Endian, the reverse done as well. Okay, so just a little trivia to start off with here. So with cross-platform database migration, your big Endian platforms are commonly things like AIX, Spark Solaris, HPUX has big Endian platforms as well. Your little Endian platforms are things like Linux, Windows, these kinds of other architectures, right? So cross-platform, or moving things from one platform to the other, would be a legacy platform to a more modern platform or a newer platform, is a common activity. And we recognize from our experiences that DBAs, you know, they have to script this quite a bit. It can be pretty complex. There's potential downtime involved, read-only, as Marco mentioned before, when doing this kind of operation. And just the time, right? Just the sheer time to convert large amounts of data to a new destination format. All that kind of is factored into a solution that we've been helping customers with, and we are now published and formally supported, is what we call zero data loss cross-platform database migration. And that's using the recovery appliance as a centerpiece to do this mass migration, if you will. The three kind of main kind of benefit points are reduction in downtime. So the system is taking all your backups as normal. The source databases are in read-write time, and you have a final read-only period where you have to take the last incremental and just the metadata export, okay, that's needed to plug in those table spaces at the destination in read-only mode. So from many hours or maybe even days of doing this kind of migration to only 2 hours or less of read-only downtime, depends on the last incremental that's taken. We also have, with the recovery appliance now, an automation tool which simplifies this steps for large numbers of data files, large numbers of databases, and the script kind of wraps up all the needed RMAN commands, as well as the metadata data pump export and import commands as well. And this procedure supports both same and cross-Endian platform migration activities. So as a high-level kind of overview, we have databases that supported from 11G to 12C with the solution. The destination has to be 12C today. We're validating a solution for 18C, and we intend to support that shortly as well. What this solution entails is basically you have both, you know, the first level 0 backup, we call a full backup, taken to recovery appliance, just like normal. And this is done for your database and includes all the table spaces. When you do a cross-platform database migration, you actually need to do this on a table space by table space basis. And again, that script I mentioned automates the whole process. So you as a DBA don't have to script this and accommodate this for every database, for every table space. The script kind of takes care of this yourself, and you can supply any number of table spaces in that script for migration. So your destination has already been preset up with system, sysbox, all the normal system table spaces to bootstrap that new destination database version. Say in this example, you're going from AIX on the source to Oracle Enterprise Linux on the destination. So you take your first full level 0 backup, full backup, and then every day, however long you want to take those incrementals, you can take daily L1s, for example, and those become virtual full backups on the recovery appliance. Now, the starting point of your migration, again, the source is still read-write, is to restore the virtual full. So you take the latest virtual full backup, and this is just prior to your migration window, say on the weekend that you want to conduct these operations. And the command you do for the restore is restore from platform. This is a 12C and above RMAN command that will restore the level 0 of all the table space data files and do a conversion of the files to the new Endian platform, okay, in this case Linux. So it'll do that restore and conversion in line, and it will physically restore all the blocks that are needed. At the time you're ready to do the switch over, the cut over from the source to the destination, you then take your final read-only in a read-only state of the incremental of all the table spaces. So this is a read, you put the table space read-only, your incrementals have been done, so you're only having to take just the changes since the last virtual full, and you also take that last export that's done as well. Okay, so the export is just for the metadata, not the user data, and the metadata entails the objects, the data dictionary objects such as field SQL procedures, etc., that are on top of the user data itself. And so you do a final restore and recover and convert of that read-only incremental backup that will allow your virtual full restored data files to be consistent to read-only state. And then you do an import of that data pump file at the destination so that it is able to, the objects are able to be imported and the table spaces are able to be materialized or be able to seen as schemas now, right? All the schema objects, everything kind of comes into view. Your destination at this point is open and read only. Okay, so you can open it read only to verify that the migrated data, do any other adjustments you need on the schemas. Then you can finally open that database or read write where the cutoff would then occur from the source to the destination. So your read only time again is predicated by the time to take that final incremental and the time it took to do the export and the import of that metadata file. And in our latest script version, you can have the data pump part of the script actually connect directly to the source and import the table metadata from the table spaces directly without having to do a staging metadata file to begin with. So now I just want to take you through a quick demo of how this occurs. Just give me 1 minute and I'll bring that up. So what I'm going to show is kind of the migration demo. Let me get it to the beginning so you can actually see the first start. And we've already started covering kind of the concept of this demo, so we'll kind of skip through this part fairly quickly. Okay, the same process here that we stepped through for the export and import. All right, so this is the starting point of our migration demo. So we have basically a source database in step 1. It's running on 11.203. It's on our big Endian Spark Solaris system, and we want to convert it to Oracle Enterprise Linux. Okay, so the first step here is we have the database. We have the destination running on Linux here on the right side. It's also ASM. Okay, so from file system to ASM, we'll do the migration. Next, we're going to run the script. So you script here, you see on the bottom right corner is called DB Migrate User Perl script. So this is the Perl script with the options, and the first command we're going to do is to do a restore of the latest virtual full. Now, this script has already been configured, so it knows about that recovery appliance backup that's already been taken. So you already have the backup available, and we're going to run the script now. So you can see here that we're going to restore that latest virtual full. If I can move this window around. And the latest virtual full, you can see, is taken from the recovery appliance. And we're going to see in the middle screen the actual tasks that are being run. So you actually can see that there's some restore task at the bottom called restore. And you can see that some tasks being run there to do the data files. So we got a number of data files that are being restored from their virtual full level 0. And we see the restoring file log script here at the bottom right, and we can see the monitoring of the restore task in the middle. Okay. Our data files are now restored to this location. It's a temporary location. We have a 11G source database. We have a staging location, and then they're restored into ASM from there. We can also check the progress of the migration. This script gives you the status after every phase is done, and you get a final result at the end as well of what's been done after restore. Now we have the copying of the data files going into ASM. So you can actually see here the files listed here. Now they're in ASM. And we're now going to go to the next step of the migration part, which is we're going to go do that final read-only incremental. Okay, so we can actually run this recover command on the script, which will recover the destination with the incremental level 1 backups. And as I said, the last one has to be the final read-only one. It's going to go through that recover from platform command, apply the incrementals. And now we're going to do the read-only mode. So now the final incremental is done. We have the top screen showing the read-only mode where the table spaces are now done. And then the middle screen is going to show the last incremental level 1 command. That's using the script as well. So let's go through here. We'll see the final read-only incremental done, and the script is run. Now we're going to do the import of the import and export of the metadata. Export and import of the metadata. So here we have the table space metadata on the upper screen. And then we have the import done on the bottom screen here. Again, of the same table space. Now we can put the database in read-write mode, and we can see that we have the same data files now converted and now put into ASM here on the left side. And they're the same files that was done from the beginning from the source database when we started from the Big-Endian platform. Okay. So check, again, very quick demo, step through of how the script works. We'll provide this presentation. We'll have the links to that script, and we'll also share this presentation with you too at the end. So we covered the benefits, reduction in downtime. The application or your source database is only read-only. During, the read-only is the downtime, right? And that's the last part of the final level 1 and the metadata export and import. We have a new automation tool to use for this. And we have this support note here at the bottom. This is a support note that has the full detail of this procedure, okay? And you'll be able to find more specifics on how to do this and on your environment. For Same-Endian, same platform database migration purposes, you can use much simpler, even simpler process using RMAN duplicate. So this is our command in RMAN to clone or to create a new database. And what you can do is create a new standby database using duplicate, again, using that virtual full backup from the recovery appliance. Then you can start up your managed recovery process. Because of the same platform or Same-Endian, you can have redo shipped and applied on that standby, right, across the source and destination. So this redo keeps that secondary standby up to date, and then you can verify the destination by opening that standby read-only, and then you can perform a switchover. So your amount of, the amount of time to do for downtime is really the switchover time, which could literally be seconds. Okay, seconds for the database side, maybe a few minutes for the clients to actually connect over as well. And we have a support note which details how to do this for 11.2, 12.1, 12.2 or later environments using this technique. So advantages, again, very low downtime because it's just using a switchover. Increased availability during the migration because you have the source available to the top. And then you have Active Data Guard. If you have that license, you can actually open that standby read-only while the MRP, the redo, is being shipped and applied. And that will allow you to do more reporting and to do other activities in line at the same time as your standby is being updated through redo. Lastly, just want to kind of share all the presentations from OpenWorld, so they go into more depth on the Marcos slides on the migration. It also has slides about customers who've used these techniques for cloud and for Exa Cloud at Customer. You can go to our Oracle OpenWorld Content Catalog website here and do a search for these session names. Okay.